Polymers, very quickly. So the first type of polymer is the addition polymer. Addition polymers are always formed from alkenes. So if this was the monomer for the alkene, the first thing you need to do is redraw it so that you can line up the double bonds with each other. So what you want to do is you want to get this CH3 group down out of the way. So I'm going to put it down here, like that, and then I can get the next monomer along in the chain, and I can put it here. And then if it helps, you can keep drawing more and more along here, but 2 is plenty. So then all you need to do is you need to break the double bond in each of the monomers. So that's going to become a single bond, and then the bond reforms between the 2 monomers like that. Okay, and then you can carry on doing more if you want, like I said, but it isn't necessary, and it should become clear then that the repeat unit is just going to be this one here. Okay, then you get rid of all that and put your end down there. Alright, now if you need to go the opposite way, so if you're given the polymer, let's say you're given something like, so it's going to be a polymer, you won't have the double bond in, it's something like this, maybe with a fluorine, maybe with a longer group here, C2H5 and an H and an H, like that. Okay, and you want to know what monomer it's formed from. It's super easy, so all you need to do is just get rid of the bonds between the monomers. So get rid of those, and then the bond inside just becomes a double bond. It's as easy as that. Now, this obviously isn't necessarily the way that we'd normally draw it, so if you want to go out and draw it like you normally would, the C2H5 is going to be a CH3 group next to a CH2 group, and then you get your carbon-carbon double bond with the fluorine on it and the other hydrogens, although that's obviously not going to work, is it? Because this carbon here has got 1, 2, 3, 4, 5 bonds. I've made a mistake there. Easy enough to make, because you can see this carbon here has got fluorine and C2H5, now it's got fluorine and C2H5 bonded to it. Alright, so addition polymers are formed from unsaturated starting materials, so they have to have a double bond in. Usually they will only have one reactant, so the way these are actually made is you take your monomer, you put it in a reaction vessel, you increase the pressure, maybe put a catalyst in, and then you get your polymer out, which is going to be a plastic. Alright, so the second type of polymer, slightly more complicated, is your condensation polymer. Now, the first type of condensation polymer is formed from a dicarboxylic acid. So let's just choose any type of carboxylic acids. That's your acid group. Then there'll be some sort of carbon chain, let's say C2H4, and then another carboxylic acid group, and then an amide, a diamine, C2H4 again, NH2. So this is your acid group, and this is your amine group. Now, like I did with the addition polymer, you can go ahead and draw out more. So on the other side of the diamine, you're going to get another diacid. And on the other side of the diacid, you're going to get another diamine. Okay? Now, you can draw those out, you don't need to. Now, if you're really not sure how this works, it's best for you to draw out the full structure. Okay? Because it's very easy, if you're unfamiliar, to remember, to forget what this actually looks like. So I'm going to draw this whole thing out. So it's going to look like that. That's my carbon chain. And we'll do an example in a minute where we use just some boxes instead of the chain. Now the acid group looks like this. So there's your acid group. It's going to be the same on the other end. Like that. Your diamine is going to look like this. Now, I'll draw out just a little bit of this one as well, but obviously it's going to look exactly the same as this one. Let's just draw that, and then let's do the other end of this one as well. Let's do C2H4 and H2. Now, it's a condensation polymer, which means you're going to lose, you're going to subtract H2O. Okay, so whenever I join the diacid to the diamine, I take out H2O. So I can see my H2O is here. There it is. Okay, so I'm going to get rid of that. So I take that out. And then I just connect the carbon with the double bonded oxygen to the nitrogen of the diamine. There it is. There's my bond between the two monomers. Okay, so same thing happens over here. I'm going to get rid of the hydrogen and the oxygen and the hydrogen from the acid. I'm going to join those together, and I can do the same over here. And I do like that. Okay, now obviously it looks a little bit funny if you draw it like this, so what we can do is we can go out ahead and just draw it out without these stupid long bonds in the middle. So we're going to get C2H4, NHC, double bond O, C2H4, that's that bit again, C double bond O, to my NH, C2H4, NH, to my C double bond O, C2H4. Now, this is the, and obviously it goes on this part, but the key now is to try and work out where the repeating unit is, okay, because this is longer than a single individual repeating unit. So let's just choose, it's easier if you start in between, you know, rather than trying to start here, that's going to just confuse you, start where you made the bond. So this bond here is in here. Alright, so I'm going to start there. So I've got my C double bond O, C2H4, C double bond O, then NH, then C2H4, then NH. And then I go back from NH to another C double bond O. So you see, this is where it starts to repeat. C2H4, NH, C double bond O. So I don't want this C double bond O in twice. So I put the bracket there. Alright, so that gives me my repeating unit. Now this is called a polyamide. Alright, the amide bond, the amide group, is this part here. And an example of this, not this example, but an example of this would be nylon. Okay, and you can look that up, or you can look in your textbook and you'll see that. Alright, now there is another type of condensation polymer. So polyamides is one type, and that's formed from a, just as the short saw up here, it's formed from a dicarboxylic acid and a diamine. You can get a second type of condensation polymer, which is formed from again, a dicarboxylic acid. Alright, now this time I will use these boxes that sometimes you see. So my dicarboxylic acid looks like this, and the second one is going to be a diol, a dialcohol. Alright, so I can do it again, I can draw, so I've got acid, alcohol, acid. You know, draw as many of these as you need to so that you feel comfortable that you know what's going on. So if I've got acid, alcohol, acid, over here I'm going to have another diol. Okay, now you should know that the reaction between an acid and an alcohol gives you an ester. Alright, so this is obviously going to form a polyester. Now it's, again, we're taking out H2O, so I can take out oxygen, hydrogen, hydrogen, or I can take out hydrogen, hydrogen, oxygen. It doesn't matter. You're always going to get the same product whichever oxygen you choose. Alright, so let's just get rid of that one, and then we just get the bond. Okay, and then you see that's the ester bond. C, double bond to O, single bond into oxygen. Alright, let's do the same over here. H, 2, O, and then I bond across there. I do the same over here. H, 2, O, and then I bond across here. Okay, and then you can see, what have I got? Well, if I start with this bit, I've got my white box, to my oxygen, to my carbon double bond, to my black box, to my carbon double bond oxygen, to my oxygen, my white box, oxygen, carbon double bond O over here, to the black box, C, alright, and then that's obviously going to carry on to the next one, and that's going to carry on to the next one. And once again, you just need to work out where the repeating unit is. So if I come in, let's say this is where I started, okay, which is going to be, where is that? This bit here, okay, C double bond O, black box, C double bond O, O, white box, O, and then I've got my next C double bond O. So this here is the same, these two are the same, so I want to come in just ahead of that, and that gives me my repeating unit. Okay, so this is an example of a polyester. An example of a polyester would be PET. This is not PET, it's an but PET is an example of a polyester. Things to remember about this is that you can break it down back into its monomers and then repolymerize it. But the last thing we need to talk about is we can, if we take an amino acid, now an amino acid is H2N, C, R, H, C, O, OH. I've got an amine group and an acid group on the same molecule. So now, rather than having a diacid and a diamine and repeating them, I can just have this one thing by itself, because if I put another one of them here, remember an R group is just any particular kind of carbon chain. If I put that there, now my amine and my acid are next to each other. Okay, so even though it's the same molecule twice, I can get the acid and the amine to line up, just like how I had when I made my polyamide here. I had the acid and the amine next to each other. Here I've got the acid and the amine next to each other again. Alright, so let's say we just take 3 different types of amino acid. Okay, one with a black box, H2N, COOH, one with a white box, H2N, COOH. And remember, the difference between these boxes is going to be the R group is going to be slightly different. And we can get even a third type of amino acid with dots in it. Okay, so all we do then is we just take out H2O. All right, so I can get rid of, if I take a H from this end and a H2O from that end, and I take a H from this end and a H2O from that end. Okay, now this might get a little bit confusing because I'm going to think that it's going to be carbon bonded to oxygen bonded to hydrogen or something like that, so I'm just going to redraw this with the double bond up there, redraw this with the double bond up there, just so I don't get confused. I'm going to redraw the hydrogen so it's not in the way, draw that down there, redraw the hydrogen as well, so that's down there, and then I get the link between the molecules. Okay, so I end up with this situation where it's N, H, yeah, so I'm going to take off a hydrogen here because the polymer chain is going to carry on along here, like that, C double bond O, N, H, and the white box, C double bond O, and the H, then the dotted box, and the C double bond O, and again, even though I haven't done it over here, it will bond to another one, so I'm just going to leave it like that. Now there is no individual repeating unit because what I've got is lots of different individual amino acids. It's not the same amino acid over and over again, it's different individual amino acids, so I'm not going to look for a repeating unit here, there isn't one, but this is the structure of a protein. Okay, so the protein is formed from amino acids by a condensation reaction in the same way that a polyamide is formed. Now the only other thing you need to know really about polymers is that especially for addition polymers, when you make things like this, these are plastics, and plastics are obviously have issues with disposal because when you form them, all of these carbon-carbon bonds are really strong. Alright, so for polyamides it's slightly easier to break these bonds, but for these carbon-carbon bonds they're very strong, so when it comes to disposal, that's an issue. And because of that, they don't degrade in the environment very easily, so they will build up in the oceans. And if you try and get rid of them by burning them, they will produce toxic gases. Okay, so just remember those three things for polymers, for plastics. Difficult to dispose, accumulate in the ocean, and they will form toxic gases if they are burned.